Alright, so I'm putting together a video that talks about a qualitative look at trigonometry. So this is like just some conceptual thinking about how to solve for some stuff in trigonometry without having to rearrange the equations and stuff like that. Just some common sense stuff. It won't help you with everything, but it will help you with many things. So let's look at two similar triangles to begin with. Okay, they're not right angles, not right triangles, but they're two similar triangles. And I'm going to call this one triangle small, and I'll call this one triangle large or big, triangle big, and I'll call this line segment long, maybe a different color, I guess. Line segment long, different colors. Oh, there's a red one down here. Okay. Line segment long, line segment long, and line segment short. Okay. And we'll say that this line segment here is 25. This line segment here is 5. That works. We'll say that this line segment is, we'll say, how about 4? Nah, we'll make it 5. Why not? Make it 5. And we're like, all right, what is this line segment length? It's pretty obvious right now what it's going to be, but let's go ahead and, for the sake of math, show you guys how this is done. Okay, this is a simple, because these are similar triangles because of angle similarity. These line segments are proportional, right? This is proportional to this one. This is proportional to this one, and this is proportional to this one. Okay, so I can write a proportionality statement. Okay, I can say, make it like two proportionalities in the form of a fraction. All right, but before I do that, I want to solve for, we'll say x. I want to solve for this x, for instance. Okay, so I want to set up my proportion in a certain way. All right, I'm using small and big. Those are the two things I need to consider, and the short leg, and the short side, and the short side and the long side. Okay. Why did I put short and long? That's wrong. It should be the the long side. This is the long side, and this is the short side. This is the short side that I'm trying to figure out of the two things. Okay, so I'm going to set it up. I'm going to be like, okay, this is the small triangle, and this is the big triangle. This is the big triangle. And then I want to have the small side. I want my x on the top, right? So I'm going to put the small side on the top and the long side on the bottom. I want to put the x on the top just because it just makes the algebra easier. Okay, so to line this all up, right? The small side, the small triangle, small side is x. I should make these green. I should make that green. So the small side triangle is x. This is 5. Is x. And the long side is 5. Right? The small side, short side is x, and the long side is 5. The big triangle is 5. The short side is 5, and the long side is 25. Now to solve for x, all I really have to do now is bring 25 over here and and solve for x, right? So to do that, x is going to be equal to, if it's on the numerator, it's on the denominator over here, it'll be on the numerator on that side. Multiplying both sides by 5. Okay, so x is going to be equal to, right, it's going to be the red 5. Well, let's do one big fraction. I want to distinguish it between the two here. Okay, so I'm gonna reduce this on purpose. So 5 divided by 25 is 1/5. 1/5, right? Times 5. Bring that 5 over. Right, 1/5 times 5. Right, the 5's cancel out, and then I'm therefore left with x equals 1. All right, so x equals 1. Okay, now I want you to think now, if I took this one out, and maybe I put another one in that was really big. Let's say it was like this big, right? And they were with similar angles, right? So there were similar triangles, okay? And this was 200, right? Would I have to do all that math again, right? Or could I just change that number to 200, right? Well, I could just change that number to 200, right? Because the ratio, the math would all just be the same. The ratio is all the same. The setup could be the same, right? So I could just change that and multiply that by 200, right? It'd be 200 divided by 5, right? 200 divided by 5, and that would be 40, right? So the reason I show you that is because this is the basis behind trigonometry, right? Is that any right triangle with the same other angle, like say 30 degrees, right, will be similar. And because of that, we can set up ratios of one line segment to the other for any given angle. Okay, let me make that a little bit neater. Okay, so I'm gonna make some right triangles here, and just give me a second. All right, so here is my right triangle. And I have a red line segment opposite a red angle. I have a green line segment opposite a green angle. I have a purple line segment opposite a purple angle. Okay, and so a right triangle is made up of 3 line segments. There is a hypotenuse, which is and always will be the longest line segment of a right triangle because it is opposite the largest angle of the right triangle, which is 90 degrees. The other 2 angles, P and R here, are going to be equal to 90 degrees when you add them up, okay? And unless, and there's one situation where they are equal, and that's when they are equal to 45 degrees. And so the length of the line segment opposite to them are a direct reflection to the size of the angle, meaning that when R is bigger than P, the line segment R will be longer than line segment P. Okay, so the R would be, in that case, the long leg, and P would be the short leg, and vice versa. Okay, so angle P and angle R add up to 50. Right, so P plus R equals 90 degrees. 90 degrees. So unless they are both 45 degrees, right? One, the opposite line segment, right? One of them will be the short leg, and one will be the long leg. If they're both 45 degrees, they're going to be equal, okay? And if one of them is bigger, the opposite line segment is the long leg. All right, keep that in mind because that's going to come in handy when we're talking about tangent, okay? So anyway, all right, so in reference to the angle theta, right? Theta, so theta, I need to use let's use, I can't use purple, can't use green. Let me use a different, let me pause this and find a different. Okay, here we go. So keep that in mind now. So we talked about the two legs that are going to be shorter than the hypotenuse. And unless this is 45 degrees, in the rare case that it is, one will be the short leg and one will be the long leg. Okay? So the relationships we talked about earlier that exist between the length of one divided by the length of the other have been defined, right, for any given angle theta, right? Theta is like the generic term or Greek letter that we've identified as like the angle that we're talking about in the problem. Okay, so when we're talking about theta, it could be this one, and it could be this one, right? And what angles are referenced as the opposite or the adjacent change based upon what angle theta is the referenced. But hypotenuse is always the hypotenuse. Okay? So I have another video explaining that stuff, right? So if this is theta, the hypotenuse joins the adjacent. So in this case, if this was theta, G is the hypotenuse joining with line segment P to make up theta. And R is the opposite. If this was theta, the hypotenuse would join R to make up theta, and this would be the adjacent, and this would be the opposite. Okay, but the hypotenuse is always the same, right? But sine is the opposite. Let's talk about the opposite one, and cosine is associated with the adjacent line segment, right? And they are both those line segment lengths divided by the hypotenuse. Okay? And because of that, give me some space here. And because of that, whether or not the opposite or the adjacent are the long leg or the short leg, it doesn't matter, right? The hypotenuse is G, right? Right. Whether or not they are the long leg or the short leg, depending on where theta is always, sine and cosine are always going to be less than 1, because this is the bigger number, the longer length, and these are going to be smaller than that. So if you take a longer length and you divide it by the hypotenuse, it's going to give you a number less than 1. So why does that help us? Okay, well, let's look at an example. Let's say that I have a right triangle, okay, and I'm given this angle is 32, okay, and I'm given this is 15, and I'm trying to find this. Okay, the first thing I need to do is what function? Okay, well, I'm using the opposite, and I need the hypotenuse. Because I'm using opposite and hypotenuse, I'm using the sine. Okay, so, well, I need to make, where's the calculator? Pause this. So I'm going to be using sine because I have the opposite and the hypotenuse. Okay, therefore I'm using the sine of theta. All right, And because I need to find the hypotenuse is going to be longer, right? So I need to make 15 bigger, right? And I know that the sine is always going to be greater than 1. So 32, and I press the sine, it's 0.55. And only the way to make that number bigger with 0.55 is by dividing 0.55 by that. All right, so I go 15 divided by the angle 32 sine equals 27.7. Right, so this is 27.2. I said 20.7. That's that, right? Which makes sense, right? So I can also even check that, right? If I want to double check that, I can do 27.2, right, divided by 15, right? Is that value? Wait, hold on. Sorry, opposite divided by adjacent. So 15 divided by 27.2 is that value. That is the sine of that angle. Take second arc sine and, oops, hold on, I messed something up. 15 divided by 27.2 equals second arc sine, and my angle, what's going on? 15 divided by 27.2 equals arc sine. Oh, it's in radians. That's the problem. Let me go off, turn it back on. Okay. All right, so I'm going to go 15 divided by 27.2 equals second arc sine, and there we go, it's 33.46. The difference being a little bit of the rounding that I did. Okay, so there you go. Okay, so those decimals matter a lot in trigonometry. All right, so now if I say, for instance, I'm given some different numbers, and we'll say that this is 61, right, and my hypotenuse is 22, and I'm trying to find this, right? Well, that's the adjacent and the hypotenuse, right? So I need to, that's going to be the cosine. That's the cosine of theta, right? So, well, if I need to make, and that's going to be smaller, right? It's going to be smaller than the hypotenuse, so 0.61 cosine is 61 cosine is that number. All I gotta do is to make that smaller is multiply it by 22, right? So this is going to be 10.66, right, to round it, right? So that is that value, and it's that simple. Okay, the hardest way to do it is to make it go up, because you have to do a couple more button pushes. Making it go down is easy. Okay, now let's talk about another one. So that's sine and cosine, right? Now we're going to talk about tangent. Okay, tangent is a whole different beast, and you have to put a little bit more brain power into it. Tangent equals the opposite divided by the adjacent, and there's no dealing with hypotenuse at all. So you have to take into consideration which is the bigger angle. Okay, so I have a right triangle. Make it obvious. Okay, maybe more obvious than that. Okay, so there's my right triangle, and we'll say this is like 20 degrees, and therefore this is a right triangle, and so therefore this is 70 degrees, right, because that equals 90, right? It's obviously that this is the short leg and this is the long leg. Okay, so if I'm given this is, we'll say 10, right? It's obvious I have to multiply something to make that longer, right? Well, if anything, your number here that you're looking at your angles at, your magic number is 45 degrees. Okay? The tangent of an angle greater than 45 degrees is going to be greater than 1. And the tangent of an angle less than 45 degrees is going to be less than 1. The tangent of an angle, that's a greater than sign. The tangent of an angle, greater than 45 degrees is greater than 1. The tangent of an angle less than 45 degrees is less than 1. Okay? And then a tangent of an angle of 45 degrees equals 1. Okay? So that means, right, that if I'm going to try, I have the short leg, right, and if I have the long, if I'm trying to figure out the long leg, right, the 70 degrees, the tangent of 70 tangent is 2.7. That means I got to multiply that by 10 to figure out the other one. That's 2.75. Okay? But if I'm trying to figure out the tangent of 20, if I have the tangent of 20, right, I'm going to have to divide it by the tangent of 20. Right? So 10 divided by 20 tangent, that's 2.7, right? So that should help you figure out all that stuff, okay, if you want to do it. Now, this is about not using algebra, okay? So just remember, right, if you're trying to make it bigger and you're using the opposite, you have to divide it by the tangent of that, okay? And your opposite's a short leg, right? So yeah. So anyway, hope that helps. If you're trying to find the adjacent, right, and you're using the adjacent angle, right, if you're trying to figure that, if this is your configuration, you have to divide it by your adjacent angle. Okay, if you're trying to find the opposite, you multiply it by the tangent. Okay? So anyway, I hope that helps out.